Okay, this is lesson 5, continued. Before we continue, I'd like to go back and just kind of review the PowerPoint notes real quick. And we'll work on some more problems. So, we're looking at simplifying rational expressions, working with rational expressions. Here we look for the common factors and cancel them out. And that way we have our answer in its simplest form. Here we multiply numerator times numerator and denominator times denominator. If we can cancel, we want to go ahead and do that. But we can only cancel from numerator to denominator. Division, we have to flip and multiply the second term, or also known as multiply the reciprocal, and then we can simplify that if that's possible. And so that's basically all the PowerPoint notes for lesson 5, part 1. And let's say that we have an expression such as 8r cubed over 6r divided by 5r squared over 9r cubed. Now, before we do anything, you want to go ahead and multiply the reciprocal of that second term. In other words, you're going to flip it and then multiply it, because you don't want to get into the habit of doing any kind of canceling before that. So we're just going to go ahead and do that first. So that's 8r cubed over 6r times the 9r cubed, that's in the denominator. Now that's going to be in the numerator. And the 5r squared is in the denominator for the second term. Now here we could have canceled before flipping it. But you want to get into this routine of doing the same thing every time, and that way you reduce your amount of mistakes that you're going to make. Okay, now we can cancel the 6. 2 is a factor that can go into 6, right? Into both 6 and 8. And we also know that 3 can also cancel into 6 and 9. So you could start either way. So I always like to start with the left and work my way to the right. And that way you don't miss anything by doing it the same way every time. So we start with the 8. And we can see that 8 can cancel into 6 2 times. So 2 can go into 8, and that's 4. 2 can go into 6, and that's 3. And then we want to see, can 4 cancel in anything? No, it cannot. Well, how about the 3? Can the 3 cancel with anything in the numerator? Anybody? Yeah, the 9, right? So 3 can go into 9, and that's 3 times. 3 goes into itself once. The 4, that doesn't cancel with the 5. But we know that the r's can cancel, right? We know that r can go into r cubed, and that'll be r squared. And we also know that r squared, that can cancel in r cubed, or you can just cancel these two r squares here. And so we'll just cancel these two r squares. They go into each other once. And so we've got 4 times 1 times 3, 4, and so that'll be 12. And then we just have that r cubed. And then here we have 1 times 5, so that'll be over 5. And so we get 12 r cubed over 5. All right, questions with that? All right, well, what if we have binomials involved, such as 5n plus 25 over 10, and that's divided by 6m plus 30 over 12. Okay, so, and we want to put a line here. Okay, first thing we want to do is flip and multiply the second term. Okay, so we're just going to rewrite the first one, 5m plus 25 over 10 times. And so the 12 goes in the numerator, the 6m plus 30 goes in the denominator. Okay, now we want to see, can we factor here? Is there a common factor? We cannot cancel the 10 into the 5, right? Why not?
You have plus 25.
Yeah, because you got the plus 25, the plus there, right? But we can factor. Okay, so we factor out 5, and that leaves us with m plus 5. Well, how about the denominator? What's a common factor there for the second term? Can we factor 6 out of both? Yeah, we can, right? Because 6 times 5 is 30, so we factor the 6 out, and that leaves us with m plus 5. So this is what we've got. We've got 5, parentheses m plus 5 over 10 times 12 over 6 times m plus 5. Now, as long as you have this m plus 5 in parentheses as a quantity, you can cancel these two. Okay, but they have to be exactly the same inside the parentheses. Well, they are, so we can cancel. Okay, anytime you cancel something completely, you want to put a 1 there. All right, well, let's see. 5, that can cancel into the 10, right? And that gives us a 2. All right, what else can cancel? Here. Travis?
6 and 12.
Right. 6 and 12, they can cancel, and that's 2. 6 goes in itself once. Can anything else cancel?
The 2 2s.
Yeah. The 2's can cancel. I'll use purple for that. Well, let's see. The 5 cancels into 10, 5 cancels itself once. So the purpose of leaving, putting a 1 here is when everything cancels, what's left? Dylan?
The 1?
Yeah, 1. Because 5, that cancels into 10 2 times. 5 goes in itself once. The m plus 5s, they're going to go into each other 1 time. The 6 and the 12, that went 2. And then the 2s, they go into each other 1 time. So all that's left are 1s. So when everything cancels, you have 1 left. Alright? Questions with that?